Okay, let's calculate the concentration of the sodium hydroxide that you saw titrated in the previous video. So first, take a look at that data table that's on the slide that shows you how much HCl and how much NaOH were used. So notice, in order to get the volume used, we just subtracted the final reading of the burette minus the initial reading of the burette to get those two values. And then in the row below that, it says the molarity of the HCl was 0.1 molar, and the molarity of the NaOH is what we don't know. That's what we're going to calculate. So the first thing we're going to do is write a balanced equation for our reaction. So HCl and NaOH reacted, and when they did that, so this is double displacement, right? So the hydrogen is going to get together with the hydroxide to make water, and the sodium is going to get together with the chlorine to make the salt, sodium chloride. And so we know the concentration of this is 0.1 molar, and the concentration of this is what we're looking for, right? And then we also know that 2.4 milliliters of HCl were used and 2.7 milliliters of NaOH were used. So what we're going to do is use this information to get to moles of HCl, and then we're going to convert that to moles of NaOH. And then we're going to use the moles of NaOH and the milliliters to get to the molarity. So here we go. We're going to start with the volume of the HCl, and I'm going to move the decimal point 3 places to the left to make the volume in liters. So here's our volume of HCl, and we're going to change it from liters of HCl to moles of HCl. And we're going to do that using the molarity. So if you take a look at the units that are here, we have moles divided by liters, and moles divided by liters is molarity. So we can put in that this is 0.1 moles for every 1 liter. That's what the molarity tells us. So let's get rid of those units. And our next step will be to change from moles of HCl to moles of NaOH. And now this is why we needed the balanced equation. So if you look at the top, you're going to see that the coefficients all the way across are 1s. So this is 1 and 1. So that's an easy step to skip, but you want to make sure that you have that balanced equation and you put the coefficients in, because otherwise your concentration won't come out correctly. Okay, so that's going to cancel out our moles of HCl. And now, if we do our math, we're going to get the moles of NaOH. So that would be 0.00024 moles of NaOH. And what we want is the molarity, and that's the moles divided by the liters. So we have the moles. Now we're going to divide by liters. Again, make sure you take that volume and move the decimal point 3 places to the left, divide by 1,000 to get it to be liters. So 0.0027 liters. And then we divide those, and we're going to round to 2 significant figures because that's what the concentration of our hydrochloric acid has. So that's going to be 0.089 molar. And that is the answer to our problem.